Hey guys, today I'll be showing you guys how to set up um, an ODE function, so a differential equation function for multiple variables. So this you will often encounter in chemical engineering or other engineering that you guys are doing. So I took a problem from Fogler, and it goes something like this. There are initially 500 rabbits and 200 foxes on a farmer's oats property. Use polymath or MATLAB to plot the concentration of foxes and rabbits as a function of time for a period of up to 500 days. And the predator-prey relationship are given by the following set of coupled ordinary differential equations. This guy is right here. And they also gave you this constant 0.02 and this uh, all of these. So I will simply show you how you set this whole equation in MATLAB in scilab. So you just follow my lead, like this type of differential. This is the same as a PFR equation, where these x's are your concentrations, and nothing, they define it as concentration as well here. So let's just get to it. So this is um, you first have to set up a function that you are going to solve. So I will say rabbit foxes is equals to so this parameter is the parameter that we will set on. So in this case it will be this t here down below. So every time you're checking the concentration of x with respect to t, so that t is the one that we're looking at. And then the second parameter, which I will simply say is a, contains both x and y. So the first parameter in a, I will simply say is x. So something like a1 will be my x, and y will be the second bit in my equation right there. Now you can start to write your differential equation. So the first one basically is dx dt is equals to k1 multiplied by your x. Let me just check it out again. Yeah, minus k2 multiplied by x and y. That's your first differential equation. Dy dt equals to k3 xy minus y, xy k4 minus y. So let me just do the last check here, so we're on track. So that's basically it, guys. You have this guy right here, and it is your set. Now it's time to put this dx dt dy dt in the output there. So you'll simply say rf is equals to The first row will be your dx dy, and the second, no, dx dt, and the second row will be your dy dt. So basically this is your setup. It looks much like uh, isothermal PFR to me. So K1 is 0.02 per day, 0.02, not 0.02 per day. K2 is 0.00 something, 0, 4 zeros and 4. And K3 is 0. Okay, and lastly K4 is 0.04. All these guys are per day, and then they told us that the final, it should be for a period of 500 days. So this T goes in days, so the concentration will be something per day. Therefore, let's set our T. Our T will be length space from 0 to 500, let's say, and yeah, just split of 1000. So, and our T0, let's say, is the first variable in our T. You also need again the first estimate, and they also give us the first estimate here. He told us that initially we have 500 x's and 200 y's. Therefore, you put it there. So your initial, so you can simply say big X naught is equals to 500. That's your first X, and 200. So this is like a column, you see. And then it's time for you to solve your solution. So your solution is ODE. Scilab uses Adams method to solve this part here. That's your first estimate, your first time variable, just like the time at each, and then the name of your ODE here, this rabbit fox. You copy that and you simply going to paste it here. And then you run it. I haven't saved it yet, so I'll just save it as rabbit fox, and it has solved. So if I can show you the x values, what are my x values? Those are all my x values there. These are all my x values. So I can do something like plot. I wanna plot t and x. I have to transpose it because my t is transposed. I will get something like this. I think it is plotted. Oh man. So you can see, wow. I can say again, legend. So the first guy is my X, the second guy is my Y, so that you may be able to see how it varies. So your X is this green guy right here. No, it's this blue guy right here. So your fox, is it your fox? Yeah, your rabbit. Wow. But you can see this guy, like, wow, he starts a bit low, but then he increases rapidly. And this guy is dropping and later on picking up for some reason also. They also asked us to change, I think. No, they didn't. So I believe that is because of those K values. What? So what do your result look like for the K's when K3 is this much, 0.0004? So you can change your K3 here, which is this guy right here. Wow, this is the first key. So I misread it initially. So it's three zeros here. Here is four zeros. So yeah, no, it was right. So I'm just adding 1 0 there, and we check the result. So I will simply do this guy right here and say run, and look at them now. Wow, they change. But that's basically how you set your game, your equation, and you simply use an ODE solver to get it right. Alright, alright, sure. That's it for me.